Okay, this is our next example. This is also done using FCFS scheduling only. In this, three processes are arriving. The inputs given are indicated at the top of the slide. The process, its burst time and its arrival time are given. P1 has its burst time of 24 millisecond and it arrives at the time interval of 3 millisecond, and P2 arrives at 0 and its burst time is 3, and P3 arrives at 1 millisecond and its burst time is 3. In this, first arriving process will be allocated to the CPU first. This is the concept of FCFS. In this, P1 arrives at 3 milliseconds only, but P2 arrives at 0 millisecond itself. So the process first arrives is P2. So it is first allocated to the CPU. So process P2 is first allocated. The process starts at 0 and the P2 total burst time is 3. So P2 ends at 3 millisecond. Then after that P3 arrives at 1 millisecond, right? So it will be on the queue. After P2, P3 will be arriving. Then only P1 will be inserted in the FIFO queue. So first P2 is completed. Next one which is in the top of the queue is P3. So P3 is next allocated to the CPU. The P3 starts at the time of 3 milliseconds and its burst time is 3. So 3 plus 3 equal to 6. 6 is the completion time of process P3. Then after that P1 will be on the top of the FIFO queue. So P1 will be allocated for the CPU. The P1 starts at 6 and its total burst time is 24. 6 plus 24 equal to 30. 30 is the completion time of process P1. This is the Gantt chart. Using the Gantt chart, we are finding the waiting time and turnaround time. As seen before, waiting time formula equal to waiting time formula equal to starting time minus arrival time. In this process P1, starting time is 6. So 6 minus its arrival time is 3. So 6 minus 3 is 3 itself. Process P1 waiting time. Then for process P2, starting time is 0. Its arrival time is 0. So 0 minus 0 equal to 0. Then for process P3, its starting time is 3 and its arrival time is 1. So 3 minus 1 equal to 2. For finding the average, we have to find the sum of all these three process waiting time divided by 3. Its value is 1.67. Then for turnaround time, the formula we are using is finding the waiting time first and adding burst time along with it. Turnaround time equal to waiting time plus burst time. So process P1, the waiting time is 3 plus its burst time is 24. So the total is 27. Then for process P2, its waiting time is 0 plus its burst time is 3. Its turnaround time is 3 for process P2. Then for process P3, its waiting time is 2 plus its burst time is 3. 2 plus 3 equal to 5. It's a turnaround time value. To finding the average turnaround time, we have to sum all these three values. 27 plus 3 plus 5 divided by 3. Its value is 11.67. This is the average turnaround time. In this, all these processes have different arrival time. We are allocating the Gantt chart on basis of the first arriving process and the first arrival time. The process which arrives first will be allocated to the CPU. This is an example, and we can see another example in which we can use the method 2 formula. In that, we can find the turnaround time first and we will calculating the waiting time next. Okay, this is nothing but this is the formula used in the previous example that's indicated in this slide. This is our next example. In this, 5 processes are given along with its arrival time and its burst time. As said before, based on the arrival time, the process will be allocated to the CPU, right? In this, the arrival time for process P1, P2 and P3, P4, P5 are given. the process P3 arrives at 0. So this is the first process which is arriving on the queue, right? So P3 will be allocated to the CPU for its execution. P3 starts at 0 and its burst time is 3. So P3 starting time is 0 and its completion time is 3. After that, the process P1 arrives at 4 milliseconds. Till that, there is no process arriving for the execution of the CPU. So, till 3 to 4, the box which was indicated in the shaded representation is the ideal time of CPU, because there is no process which is on the queue for its execution. So, CPU is free. But at the time of 4 milliseconds, the process P1 arrives. So P1 starting time is 4 and it ends at the time of 9. That is 4 plus P1's burst time is 5. So 4 plus 5 is 9 is the completion time of process P1. After that, the process P5 arrives at the time interval of 5 milliseconds. So it will be placed in the head of the queue. So now process P5 is allocated for CPU. Process P5 starts at 9 and its burst time is 4. So 9 plus 4 equal to 13. It's its completion time of process P5. Then process P2 and P4 arrives at the 6 millisecond and it is on the queue. So we are considering P2 arrives first. So P2 is allocated to the CPU. Starting time of process P2 is 13 milliseconds plus its burst time 4. 13 plus 4 equal to 17 is its completion time of process P2. Then finally the process P4 is allocated to the CPU. Process P4 arrives at 17 milliseconds. 17 plus its burst time 2. Totally 19 is the completion time of process P4. Using this Gantt chart, we are going to find the turnaround time and waiting time in this given example. The formula used to find the turnaround time and waiting time is given here. Turnaround time equal to completion time minus arrival time. Then using that turnaround time, we will be finding the waiting time by subtracting the burst time from it. Let's find the turnaround time first in this example. Turnaround time equal to completion time minus arrival time, right? So for process P1, 4 is the starting time and 9 is the completion time, right? So we are considering completion time minus arrival time formula, right? So for process P1, its completion time is 9 minus its arrival time is 4. 9 minus 4 equal to 5 is the turnaround time for process P1. Then next for process P2, its completion time is 17. 17 minus its arrival time is 6. So the value is 11 milliseconds is the turnaround time for process P2. Then for process P3, its completion time is 3 minus its arrival time is 0. So the turnaround time for process P3 is 3. Then for process P4, its completion time is 19 minus its arrival time is 6. The value is 13 milliseconds. Is the turnaround time for process P4. Then for process P5, the completion time is 13 minus its arrival time is 5. 13 minus 5 equal to 8 is the turnaround time for this process P5. Then next we are going to find the waiting time of all these processes. The formula we are using is waiting time equal to turnaround time minus burst time. So for process P1, the waiting time equal to turnaround minus burst time, right? Turnaround time is 5 for process P1 minus its burst time is 5. 5 minus 5 equal to 0. Then for process P2, waiting time equal to turnaround time of P2 is 11 minus burst time of P2 is 4. 11 minus 4 equal to 7. Then for process P3, its turnaround time is 3 minus its burst time is 3. So 3 minus 3 equal to 0 is the waiting time of process P3. Then for process P4, its turnaround time is 13 minus its burst time is 2. So 13 minus 2 equal to 11 is the waiting time of process P4. Then finally process P5, its turnaround time is 8 minus its burst time is 4. So 4 equal to its waiting time of process P5. Then as said before, for finding the average, we have to sum all those 5 values and divide it by 5. It is given here the average turnaround time for the 5 processes are find. Average turnaround time value will be 8 and average waiting time is 4.4 milliseconds. The book which I have read is Operating System Concepts, and thanks for the day.